In this video, we're going to do some more application problems. You can probably read through and do some of these on your own and then check back against the video because we've done some things that are similar. This first one, a box is made from a rectangular piece of cardboard. It's 25 inches by 50 inches. Originally, here's my rectangular layout. And then we're going to take a little bit of each corner, X. We don't know how much, it could vary. We're going to see how we could just make a function, and then later on, like in your calculus classes, you're going to optimize that. We could actually even find that out, what would be the maximum volume that we could get to by using Desmos. Okay, so on this one, we have the length is 50 right here, and our cut is X. So we can only cut so far till we start just coming out the other side, right? So how can you make a an expression to represent length using X? Okay, so think about that. So this little bit is X, this little bit of X, this whole thing is 50. The width is 25 inches, and then we have these little bits cut off. Okay, so write down your volume formula and declare your variable and put your pieces together and check back. Okay, so what I've written up here is 50 minus 2x would be this piece here after I make the cuts. That's what's left of my, edge of cardboard, so to speak, and then those are going to flip up. And the width would just be this little piece right there that I'm highlighting. And that would be 25 minus 2x. And I took those here, so I have the length times the width times the height, which I am calling x. So you would want to declare your variable to be length x would be the height. Okay, so then that's how it fits in with the volume, and it's in cubic inches. Now we would just leave it that way, would be fine. You could pop it in Desmos to see if you could find the maximum value of x, or the value of x that maximizes volume. But all I want you to do for these is just set them up. Okay, so the domain, so just to be clear, this would be your full answer here. I'm not going to try to figure out what x is. The domain is the other part of that, and so anything reasonable, I think something bigger than 0, because if you just had 0 for your x value, then you actually just wouldn't even have any box. You would just have the flat sheet of cardboard, right? So we could start at something higher than 0 and then go up until, well, really we can't go past, for this one, we can't go past 25, right? Because then I'll be cutting into the other side. But we also have to consider this width is even shorter. So if I start going, once I get to the halfway point, that's 12.5, then I'm just going out the other side. So that wouldn't really work if I did that on both sides. I would end up with just cutting all my flat part up. So I would say up to 12.5. And that would be it for that answer there. Just to say that's our reasonable domain. Okay. For number 2, I'm just starting off with a little sketch already there. A rectangle is sitting with its base on the x-axis and its left side at x equals 9. Its top left corner touches the curve at it touches the curve y equals square root of x. Express the area of the rectangle as a function of the x-coordinate of its bottom left-hand corner and state its domain. So if I think about what's happening, I wanted to draw in the, coordinates there. So the XY axis. And then I also want to sketch in my y equals square root of x because I need to have that. And then I have to think about what's happening. So I have my rectangle. It is sitting with its base on the x-axis. So the base is somewhere here, right? Some arbitrary position there. I know that the right side is at x equals 9. It touches where that is. So I know, I'm just going to sketch in here, that I would have 9 there. Okay, but I don't know what this piece is. I don't know exactly where to position what that is. So I'm going to call that X over here, this little chunk. I also am given, let's see, express the area. So I know that I want to find area equals length times width. Okay, so I have to kind of figure out, like, what is this piece in here? What can I call that? And then I also need to think about, like, if it did sit somewhere like this, the rectangle would come up and over, right? So what I know what that point would be, but how about this one? We have to get that written out. So first of all, thinking of this point, it would be, I know that x has to be 9. So then my square root of 9 would be 3. But I'm just going to write it as square root of 9 in there. And that way I can kind of just think in terms of the square root, that if this one is x right here, this point is x, or actually I should write it over here, I'll write my x, that would be the point x square root of x. Okay, so I kind of wrote it like that. And this is going to be the width. So if I can think about what the length is, so I'm going to be looking at a of x, okay, and then the length here I could represent as 9 minus x is the length of my rectangle, and then the width would be my height here, which would be the square root of x. Kind of similar to how that point was laid out, right? It's whatever it is on the curve, the y component of your x, right? So, and that would be in square units. And we could leave it that way, just like we did before, or you could put it into Desmos if you want, and then just see what the graph looks like and everything. The next part is just find your domain. And so again, kind of think what would be reasonable. Well, anything above 0, I would think including the 0 probably wouldn't work. It would just be a straight line, right? It wouldn't be a rectangle. But, I guess you could, at least it would be something, right? So you could include that if you wanted. I'm not going to. 0 less than x, and then I would go up to 9. Because that is where it has to sit on there, so I can't go past that. And that would be your answer to the second part. Okay, so the remaining 3 problems are more involved. They take a little longer, so I'm going to do them each in a separate video. But go ahead and try to set them up, like at least see if you can get the diagram going and figuring out the parts. I'll give you, a little hint with some of them. You're going to be using some distance formula, or like the Pythagorean theorem will be helpful there. Know your shapes. You're going to have to deal with some triangles and things. And let's see, the desert problem. Think about what your time is relative to distance. So you might want to kind of work your distance formula around and think what's being represented here. And then for the last one, you're going to draw a cylinder inside a cone, and then think about similar triangles. Okay, so that may help get you started and get it set up. And remember, we're just looking for the function. It can just leave it in factored form if you want. You don't have to expand that all out. And then what would be a reasonable domain? What would make sense? Okay, so I will see you back in the other videos. Have a great day.